Hi there, I'm Dr. Craig Anderson from the University of Glasgow, and welcome to the 2023-24 William Guy Lecture. I'd like to first of all thank the Royal Statistical Society for appointing me as the William Guy Lecturer for secondary schools for this year. The purpose of this William Guy Lecture is to highlight the importance of statistics in the battle against climate change. And it's a really important topic. It's something that I work on personally, and it's really a pleasure to be able to share some of the things that I've learned with you. And it's really great to have the opportunity to speak to people at your stage of education. I studied mathematics, or I went to university to study mathematics, and it wasn't until I got to university that I understood or knew anything about what statistics as a subject was. And it's really nice to be able to hopefully make you aware of what statistics is earlier on than that, and hopefully inspire some of you to become our future statisticians. Without starting out by just explaining what statistics is, I think it's actually better to just get into my topic, which is to use statistics to monitor air pollution across the UK. So why do we care about air quality? Well, roughly 9 out of 10 people worldwide live in places where the air pollution levels exceed the guidelines set by the World Health Organization. And what that means is only about 10% of the people in the world are actually breathing clean air. Clearly, that is a bit of a problem, and it's something that we would hope to resolve. And many parts of the UK have air pollution levels which exceed that legal limit as well. And so we've got an image here from London, where we have seen that local community groups have been kind of campaigning to bring in low emission zones. Indeed, we've seen low emission zones being introduced in some of the largest cities in the UK, and a lot of that work on introducing those has been a direct result of some of the work carried out by statisticians, including some of my colleagues. So part of what we're going to talk about in today's talk is the things which have led to that. How have we been able to come to the point of understanding where air pollution is high, and how have we been able to understand the potential impacts that can have on people's health? So the World Health Organization estimates that around 1 in 9 deaths around the world are down to, or are at least directly, or in some way contributed to by air pollution. And outdoor air pollution is believed to cause around 3 million premature deaths every year. For the UK, the Royal College of Physicians say that it's around about 40,000 deaths per year are contributed to by air pollution. And this could cost the UK economy as much as £54 billion. There are a number of reasons why air pollution is a big problem for us in the world. It impacts on health, it causes people to die sooner than they should, and it also has a big hit on the economy through a number of reasons. So we can understand very clearly why knowing about air pollution and understanding how to tackle it will be hugely important for everyone around the world. So where does air pollution come from? And this might kind of seem like an obvious question, but it's important to think about the main sources of air pollution. So in this image, we can see that there are factories blasting out gases. These gases are going into our atmosphere, and these gases are making their way into people's lungs when we breathe. We can also see a very large road running through there, and traffic is another major source of air pollution. Many of us will go on aeroplanes when we go on our holidays, and there are lots of aeroplanes flying around the sky, and you will be aware that aeroplanes also produce quite a vast amount of air pollution. And we can see that again from this image, the fumes coming out of the plane. Those fumes are going to at some point make their way into people's lungs. And we also have generally just cities and homes. So people who live in cities will be aware that there are often large amounts of gases being emitted from houses, from buildings, from offices, anywhere that people are, we tend to produce air pollution. So those are some of the more obvious sources of pollution. But there's also this plot produced by the Scottish Government in one of their reports, which shows some of the sources of pollution. So some of those that we've already covered are included there. There's also things like agriculture, farming, also natural sources such as volcanoes and wildfires. These aren't things we can necessarily control very well, but they do still produce pollution. We have things like ships offshore are producing pollution. And what we've also got in this image is we can see some of the many gases and other pollutants that are put into the air. So things like carbon monoxide, sulfur dioxide, nitrogen dioxide, ozone, you'll be familiar with these things. These will be terms that you've heard of before, but there are also quite important pollutants known as particulates or particulate matter. And these are just really small, essentially pieces of dust. And these small pieces of dust also find their way up into the air from roads, from just being swept up by people, and generally just being put into the atmosphere. And these are things that people breathe in on a regular basis. And it has been shown that these can be quite dangerous. And so it makes sense, therefore, that we may wish to measure the level of pollution around the UK. And to do this, a number of these air pollution monitoring stations have been installed in several locations around the country. This one, I believe, is in Edinburgh, but now that you have been introduced to the existence of these air pollution or air quality monitoring stations, as soon as you're told about them, you start to notice them everywhere. That certainly happened to me when I was first finding out about these, and then you'll go out a walk and there's one in the town that I live in, and as soon as you know that these things exist, you start to spot them everywhere. So the next time you are out and about, especially if you live in a city or if you live perhaps near an airport or near kind of factories or places like that, keep an eye out and you may well spot one of these. But these air pollution monitoring stations can come in all shapes and sizes. So in Edinburgh, we've got this rather large green one, and it's obviously very well labelled. However, some of them are smaller. We can see the one on the left-hand side is just round the corner from my office at the university, and it kind of blends in. It's just a box that sits in a car park. It could be anything. It could be a public toilet. It could be anything at all. But we can see the little kind of mesh box sitting on the top, and that actually has several instruments in it which will measure the air nearby. And that's quite near a very busy road. So part of the purpose of situating it there is obviously to pick up some of the emissions that are coming out of cars, and to basically assess how clean and safe is the air in that area. The one on the right is in Marylebone in London, and again we can see that doesn't look anything like an air pollution monitoring station. It looks like a lovely wooden building. It could be a bike shed, it could be anything at all, but that is one of the more modern air pollution stations. And again, you can see, once you look closely, some instrumentation on the top of it, which is measuring various different types of pollutants in the air. And again, you can see that that's very close to the road. You can also see that there are several bikes nearby. Again, you can imagine if you are cycling or walking or doing any sort of activity outside, you're breathing in that air. And when you're doing exercise in particular, you're breathing in lots and lots of air. And it's really in everyone's interest that that air is as clean as possible. And so the entire purpose of all the monitoring that we're doing is to make the air that we breathe as clean as possible. And the Environment Agency manages around 300 of these monitoring stations across the UK. So across the entire country, we have 300 of them managed by the Environment Agency. There are actually other stations which are kind of managed by different organisations, but the largest network is this one, which contains around 300 stations. And they measure a variety of pollutants, and it includes several of the ones that I've already highlighted earlier in the talk. So particulate matters are being picked up, nitrogen dioxide, carbon monoxide, sulfur dioxide, ozone, and several other ones are being collected. And most of these stations collect data on an hourly basis to allow us to assess air quality in real time. So once an hour, or even more regularly than that, they will gather information about the quality of air in that area, and they'll transmit them back to somewhere where the data will be collected. And actually you can access and view live data on the DEFRA website. So you can actually see on DEFRA's website that there are a number of, or an interactive map which shows basically all of these sites that we're talking about, and gives an idea of the pollution level. So the numbers actually correspond to the pollution levels at those areas. So for example, we can zoom in on a station in Edinburgh here, and we can get some information about the site. So we can actually go on there. This will actually, if we want to give you the data, it's showing you on the map exactly where it's located, and it's actually also showing you exactly what that monitoring station looks like. So we can pick somewhere else in the UK. So let's go down to Wrexham. We can see, again, where the site is, what it looks like. We can see that one's kind of hidden away somewhere by the side of the road. We can see exactly where it's located, And we can also get some information about, what pollutants it measures, the heights, the numbers of those pollutants, and so on. So there's actually lots of data being provided about these sites. And you can see, for example, the highest pollutant seems to be in central London at the moment, and that's not surprising. London has some of the highest pollution levels in the UK. It appears to be in Ealing. And again, you can get information. You can actually find information about graphs of hourly measurements for these locations, so you can see exactly how much of a particular pollutant there has been in any of these locations. So that information is actually all available at your fingertip as a member of the public. And if there are sites in your local area, then obviously it can be really useful for you to understand how much pollution there actually is in the area that you live in. So that leads us to the first part, because so far you might be wondering, okay, there's lots of air pollution monitoring stations out there. You've told me a little bit about air pollution, but where is the statistics here? Well, a lot of the statistics comes into the question of where do we actually put these stations? So imagine you are being given the task of essentially deciding where to put all the monitoring stations across the UK. And you've been told we've got the funding to build 300 of these stations. Where would you like to put them? I'd encourage you to maybe stop the video now, have a pause of the video, and actually think about this for yourself. Have a discussion if you're in class. Where are we going to put these stations? What might be a useful strategy for doing this? So some approaches that people could take. You could decide, well, let's just group them all together in one place. Is that a sensible suggestion or not? I don't know. What that's likely to do is you're likely to get a very, very good quality measurement in that particular area that you've zoomed in on. I think here we've kind of centred it around about Sheffield. So you would get a really good estimate of what the pollution level was like in Sheffield. But clearly you're not really going to get a good estimate of what's going on in Scotland or Northern Ireland or indeed the southern part of England at all. So that might not be the best approach. Another thought might be, well, why don't we do it? And I suspect this might have been one of the suggestions that might have come up if you did think about it in your class. Why not have them kind of evenly spread across the country? And that would obviously make sense as an approach. We could start to put them, we could almost build a grid of the United Kingdom and just say, okay, let's evenly space all of these stations out so that every area has one. And that is close to what might be done, but there also has to be some further considerations. So think about that now. I'm telling you now that spacing them out evenly is close to what we want to do. You've already obviously seen on the map where the real ones are located, but can you think of something else apart from geography that might have to be taken into account when we are deciding where to place these stations? Well, one of the things that's also going to be quite important is to put them close to where people live. And there's a number of reasons for doing that. First of all, we already explained earlier that many of the things which actually cause pollution are driven by people, or driven by human beings. If we have a remote area in the Scottish Highlands or in one of the national parks or something like that where not very many people live, there aren't very many roads, there aren't airports and factories, the pollution level isn't actually likely to be very high. And therefore, having a monitoring station there is a bit of a waste. If these stations are expensive, all that monitoring station is going to tell us is the air there is not very polluted. But we probably kind of already knew that. We probably already thought, if I asked you before this talk even started, which areas are going to have high pollution, you would probably already, or low pollution, you would have probably already pointed to those areas where people don't really live. And given that the whole point of our monitoring process is to understand where pollution is highest because that has the health impacts, we might start to say, well, maybe we actually want to have slightly more of our stations where people actually live. That might also lead you on to a second consideration of putting a second reason for why we put stations where people live. We've already talked about the health impacts of pollution, the fact that pollution can cause death, the fact that pollution can be responsible for several kind of fairly major health conditions. So it would be quite sensible to try to measure the pollution levels where people live, so that if we do have high levels of pollution in those areas, we can quickly identify and hopefully take steps to prevent it. We talked about those low emission zones earlier. Those would be an example of one of the kind of things that we could do. So actually, what ends up happening is, yes, we have a bit of a geographical spread across the UK, but we also make sure that there are many, many more stations in the areas which have lots of people and which are highly polluted. And so we already saw that monitoring station map. And what we can see there is that we have a number of stations across the UK. Most of them are in or around cities. So you can look at Scotland as a nice example of that up the top there. Inverness, Aberdeen, Dundee, Glasgow, Edinburgh. The major cities in Scotland all have these monitoring stations in them. We have vast areas in between which don't have monitoring stations. We may have one or two in rural areas, but the majority are based around cities. The same is true around about England. We can see lots and lots of stations round about London. We can see lots and lots round about Birmingham, Liverpool, Manchester. In Wales, we can see lots of them round about Cardiff and Swansea. In Northern Ireland, we can see lots of them round about Belfast and Londonderry/Derry. And we can see, therefore, that there are lots and lots of monitoring stations where people live and where cities are, because that is likely to be the source of the most pollution anyway. And if we want to see, if we are setting out to try and improve people's health, we want to put the stations in those locations. And this is an example of where statistics comes in useful, because one of the key things that you can learn as a statistician is about understanding data and understanding how to optimize problems like this, how to solve a problem where you have limited resources, i.e. the number of stations, and you're trying to measure something in particular. And that is a role for statisticians, to try and work out where are the best places to put these stations. And when a new station is added to the network, a lot of statistical thinking will go into deciding where it should go. So that's part one. We've got our stations here. Now we have to think about estimating the pollution levels. And our job as statisticians is to use the data from these stations to develop a picture of the pollution levels across the entire country. So if we only have these 300 stations, there are actually many towns and probably even some cities where the pollution level isn't being measured at all. We can go back to this map. I already identified that there are big gaps in our estimation. Those gaps, we've said it's because we aren't as interested in, or there aren't as many people living in those areas, or pollution we don't think is as high. But we can't just assume that. We still do have to understand what's going on in these gaps. So how do we estimate pollution levels at locations where we don't actually have a monitoring station? So again, I would encourage you to maybe pause the video and think about how we might try to fill in those gaps. Think about it from a mathematical point of view. Think about it as a problem where you have some information about some surrounding areas, but you don't know what's going on in the middle. So we can start with a simple example. Suppose that we had a couple of monitors at locations A and B. So we've just got two monitors and we space them exactly 3 kilometres apart. So you can think about that, monitor A and monitor B, and there are 3 kilometres between them. And suppose that monitor A has a pollutant level of 100 and monitor B has a pollution level of 70. How would you estimate the pollution level at the point directly in the middle of those, right in between them? So again, have a think about it. If we were to try to guess or estimate what is the pollution level directly between those two locations, how would we do it? So the obvious answer, and indeed the correct answer essentially, is just to take an average of those two. We know that they are equally far apart from monitor A and monitor B, so it seems likely that the pollution level is as influenced by one as it is by the other. So we might just decide to take an average. We said that they were 170, the two A and B. So 100 plus 70 divided by 2 is 85. And so we might say that the pollution level in that central point is estimated to be 85. It's directly between the two of them. Then we can start to extend this idea and think about it in a slightly different way. What about if we were asked to estimate the pollution level at a different point on the line? What if we were to ask to estimate it at a point which was 1 kilometre from location A and 2 kilometres from location B? Now we want to give more weight to the monitor which is closer, but still use the information from the other monitor. So this time we're starting to think about the problem in a slightly different way. We still think that the value is going to be somewhere between 100 and 70, so it's still going to be in that range somewhere, but we probably think that it's going to be closer to 100 because it's closer to location A. And if that is the case, then how might we do this calculation? And one thing we can do is to basically calculate what is known as a weighted average. We can give extra weight to the point which it is closer to, and that can be done relative to the distance. So if we know that the point is twice as close to location A as it is to location B, then why not, when we're doing the average, multiply the value from location A by 2 and just include the value of location A once, and then divide all that through by 3. So you're going to have 2 times 100 plus 70 is 270 divided by 3, and we might estimate the pollution level at this unknown point as 90. And you can see that by following that logic, you could actually probably draw a path all the way between 100 and 70 with an ever decreasing pollution level as you move from point A to point B. And that's a simple concept. That is a concept that you can understand, hopefully, from the mathematics that you already know. But as with much of what we do in statistics, actually the idea behind more complicated processes in statistics comes from something simple like this. Because what we actually do in statistics is use this simple logic to include information from lots and lots of nearby stations. And we develop a statistical model to estimate the pollution level at any location on our map using data from all of the stations which are nearby, weighted based on the distance between our location and the monitoring station. So if we have some maximum distance that we classify as nearby, our point might have 10 stations, which is within a certain range of it. And what we will do is use the information about the measured level of pollutant at each of those 10 stations, but we will also take into account how far away our location is from each of those stations to make sure that the closest stations have the most influence. And so you can think about that as kind of drawing a big circle round about our location and measuring the distance from all the stations within that circle. And by doing that, we can produce estimates for the entire UK of their pollution levels. And what we can see here is that although we only measure the pollution at 300 points, we can actually produce this map which provides an estimate of the pollution level across the entire country. And what we can see here on the left-hand plot for nitrogen dioxide is that it appears that most of the UK has quite a low level of nitrogen dioxide as measured by the dark blue. But we can see again in central London and perhaps in little pockets of other cities, the pollution levels can be a little bit higher. And we can see the same thing for PM2.5, which are these particulate matter kind of specks of dust, which are 2.5 micrograms or smaller. And again, we can see an interesting pattern, which is that the highest levels of these pollutants are in London, and there's definitely a kind of decrease as we move further and further away from London. What we are seeing is that we have used some statistical modelling to take the data from 300 points and turn that into an estimated map of the whole of the UK. So that's very interesting, and it explains one of the ways that kind of the government can measure air pollution. But what about you? How can you get involved in this? The first reason I wanted to talk to you about that was to show you that the mathematics that you learn at school can eventually be scaled up a little bit to solve really important real world problems, and that the topic of statistics, my subject, the subject that I'm really passionate about, plays a big part in that. But how can you get involved? Because this is the other thing that I want to talk to you about. These monitoring stations are large and they're very expensive. And that's why we have so few of them across the country. But in recent years, there has been a lot of work has gone into developing smaller, cheaper monitors which can also measure air pollution levels. And across the UK, there are a number of community projects that are using these monitors to kind of measure the pollution in their area. So this is an example from Breathe London, which is a project set up across London to try and encourage local communities to install or use pollution monitors in their local areas. And you can see a large map of all the pollution monitors that are across London. And on their website, you can actually kind of buy and install these pieces of equipment, and they're ideal for things like schools and community groups because they provide a lot of really important information about how clean the air in your area can be. There's also a project in the east coast of Scotland run by the University of Edinburgh in their IoT in Schools project. And they've installed monitors in schools, in community centres across Edinburgh, but also in a zoo. And I found out about this recently, that the children who were involved in the project decided that they weren't just interested in how humans, the impact of humans breathing air, but what about animals too? So the project arranged for a pollution monitor to be put in a zoo to measure the quality of the air being breathed by animals. And the advantage of having these monitors is that the local community can actually have access to the data from their area straight away. And you can see exactly what the quality of air is like where you live. And I think that's really important because it lets you get involved in the topic of statistics. And that means that you feel part of this movement to measure and understand air quality. And why is using local data like this good? And well, these monitors are really cheap and they can increase the coverage of our air pollution monitoring networks. So if we think back to that big map that we had of the monitoring networks in the UK, we can actually use these smaller air pollution monitors to kind of plug in all the big gaps that exist. However, the downside of that is that these smaller monitors are much less accurate than the larger, more expensive ones. So we need to find a way as statisticians to combine these two different sources of data and taking the levels of accuracy into account. We want to be able to produce maps that show the level of pollution in the across the whole country, and that use the monitoring station data and the data from these smaller local monitoring stations, but also take into account the fact that the monitoring stations, the big ones, are much more accurate. And this is actually a topic of a lot of ongoing research and statistics, and it's some of the work that I'm carrying out at the moment kind of looks at things like this. So another thing to think about is how might you do this? And this is not something I'm going to answer in today's talk, but I would love it if it sparked a little bit of a discussion in your class, or if you could come up with ideas of ways of doing this. And I would actually be delighted if you got in touch and told me, you know, what are the things that you've come up with? How have you thought about doing this? Because the point of this talk is to get you thinking about how we do statistics and how statistics can be useful here. So what have we learned from today's talk? Well, we discovered that, and we may already have known this, that air pollution contributes to a number of health conditions and is responsible for many, many deaths around the world. And therefore, it's really important to monitor the levels of pollution across the UK. And by doing statistical modelling, we can use the data from monitoring stations to identify the most polluted areas. And schools and community groups can get involved by setting up local air pollution monitors and joining one of those many networks that we've established. And so I just want to take this opportunity to thank you again for the opportunity to speak to you about this. I hope that you have enjoyed our talk, and I would be absolutely delighted if you got back in touch with me to discuss anything about this talk. And thank you once again.